Gravitational wave astronomy has just taken a big leap forward. The LIGO-Virgo-CAGRA collaboration has released its latest detection catalogue called GWTC-5, compiling nearly 400 cosmic collisions between black holes and neutron stars. It's the largest single addition to the gravitational wave catalogue ever made, and it's revealing that the universe doesn't just make black holes one way, it has several distinct assembly lines. Gravitational waves are ripples in the fabric of space-time produced when massive objects, like pairs of black holes, spiral together and merge. LIGO and Virgo detect these ripples using laser interferometers, instruments that measure the stretching and squeezing of space itself as a wave passes through. Researchers from Monash University and the Arc Centre of Excellence for Gravitational Wave Discovery, OzGrav, led the Australian analysis. Project lead Dr. Sharon Banagiri said the data clearly shows black hole binary mergers forming in several different ways. Some likely form when a massive gas cloud collapses to produce two massive stars that then both become black holes. Others are black holes that wander into each other inside dense star clusters. And a third group appear to be second generation, products of an earlier merger between two black holes. That last category is particularly interesting. Monash's Professor Eric Thrane noted that some of the newly detected black holes are spinning extremely fast. If the Sun became a black hole and rotated that quickly, it would complete several thousand rotations per second. These rapidly spinning black holes tend to cluster at specific mass ranges, 10 to 20 solar masses and above 45 solar masses. The heavier ones are more likely to have formed hierarchically from earlier mergers. This is a preprint, not yet peer-reviewed, but the scale of data behind it is unprecedented. Direct from the TrekZone studio in Brisbane, this is a Talkin' Science Daily Bite.